Let us look at another type of transformation. Now, we have already done four major type of transformations. Let us look at this transformation, wherein what I'm doing, I have an original function y equals to fx, okay? Y equals to fx is my original function. Now, the question that should arise in my mind is that what happens if I give this value x a modulus function, okay? What if I only want to look at the absolute values of x, okay, so that I only have positive x's and not negative x's? So what will happen when instead of x we put mod x? Modulus will make all our x's positive. My x will be absolutely positive because it's going to be the absolute value of x, and by now you must know what is an absolute value. So absolute value of x equals to positive x when x is greater than or equal to 0, and it's gonna equal to minus x when x is less than 0. So this minus, what will this minus do? This minus will make this x positive because minus minus will be positive, okay? Because my x is negative, and if I put a negative sign ahead of that, that will make it positive. So we just ignore the negative part of the graph of fx. So my original graph is fx. My original graph is fx. I just need to now ignore the negative part, the negative part of the graph of fx, because my x's are all positive. Let us just clear it out with, an example. Let me just take a very simple example. Let us take our fx equals to y equals to 1 upon modulus x plus 1. So in case when I want to see the function 1 upon mod x plus 1, this function will behave much like my function 1 upon x plus 1. And what will the function 1 upon x plus 1 behave like? It will simply behave like the function 1 upon x. What is happening is that for each value of x, I'm just adding 1 in the denominator, okay? X is in the denominator, I'm just adding 1 to it. So in case, if my x is 2, my function becomes 1 upon 2. Now, because I'm adding 1 to x, what will happen? My function will become 1 upon 3 instead of 1 upon 2. You understand what I'm trying to say? I'm trying to say that, say, if x equals to 2, then my function fx equals to 1 upon 2. Now, what will happen is that my denominator is getting increased by 1. So, this time my function will equal to 1 upon 3 instead of 1 upon 2, because this will equal to 1 upon 2 plus 1 in the denominator. So but the behavior of the function will be similar, okay? So let us just figure it out, how it's going to look like on a graph. So let us first see the graph of 1 by x. Then we'll try to figure out what will be the graph of 1 upon x plus 1, okay? Now, 1 by x is a function which will be asymptotical at 0, right? Because 1 upon 0 is not defined, okay? So, be it positive value of x's or negative value of x's, it's going to look like this, right? It's going to look like this. The function will look like what I've already drawn for you, like this. It will keep on moving, parallel to the y-axis around 0, because at 0 it's not defined. On both the sides, okay? On both the sides it's gonna be like this. Now what will happen to 1 upon the graph of 1 upon x plus 1? Now the graph of x plus 1, what will happen? This function, instead of being not defined at 0, this function is not defined at minus 1, because what is happening at minus 1? At minus 1, this function is becoming 1 upon minus 1 plus 1, which is 1 upon 0, and that is not defined. So you understand, this function will be asymptotical where? it will be asymptotical at -1. Why? Because at -1 it will never be able to touch the line, vertical line at -1. Okay, it will keep on moving there. It will keep on moving there to infinity. Okay, so this will be asymptotical like this. Instead of at 0, it will be asymptotical at -1. Okay, so that's the graph of 1 upon x plus 1. Now the question arises, what happens to the graph of 1 upon x plus 1 when the value of x's that I put are absolute values? No negatives, only absolute values, no negatives at all. In that scenario, I'm going to have a concrete graph. In that scenario, what will happen is that, say, let us put points to be more concrete in our discussion. So mod x is what? It is positive x when x is greater than or equal to 0. It is negative x when x is less than 0. Now let us just give it some numbers to this function. What happens to this function when x is 0? Mod x plus 1. When x is 0, mod x is 0. So 1 upon 0 plus 1 makes it 1, right? So this will become 1. What happens when x is 1? When x is 1, what happens is that mod x again is 1. So 1 plus 1 will make it 1 upon 2. So you will have the y value 1 upon 2. Now the question arises, when I have a negative x, what happens to the functional value? When I have negative x, negative minus 1, when I put mod, -1 becomes, when I put mod, -1 becomes 1, and I will again have the value 1 upon 1 plus 1, which is 1 upon 2. So I will have the same value. So you understand, my y's are all positive below 1, because 1 will be the highest value, right? Because it's a fraction. The function given to me is a fraction. Okay, 1 will be the highest value, right? So it will keep on moving almost like parallel to x-axis for the bigger x's. Okay, the bigger the x becomes, the smaller the y becomes, but the values on negative and positive sides will be same. Okay, the values, say this is 1, this is -1, the functional value is still half. So 1, this point is 1/2, this point is -1/2. Okay, so the functional values will be same for positive and negative x's, and it will go like this. They will keep on becoming minute as x's increase. Okay, as x increases, it will keep on becoming minute. Okay, so that will be the graph of 1 upon mod x plus 1. Okay, so all the y values will be positive. Now the logic behind is that, as mod x is always positive, we have to remove the portion of the y equals to fx graph, fx that we took, where x is less than 0. So what is happening is that I'm gonna have what will happen is that in this graph, what will happen, you just neglect the negative part out here. So my fx is this, my new fx, okay, my new fx where I have mod x, okay, 1 upon where I have 1 upon x plus 1, I remove this portion, neglect this portion, and in fact this portion will become all positive out here, and that is coming like this. So the negative y's will go away, okay, because I have modulus in my for all my x's I have modulus.